Awesome. So I'll be talking about contributing to Swift and sharing a little bit about my experiences. So first, to get started, you need to determine what you want to work on, whether that be a bug or a feature. Then compile it from the source. Implement your fix, and then unit test and benchmark your code. Then create the PR. Now that's important that you benchmark your code if you need to. There's a step in the Swift setup guide that lets you skip the benchmarks. Don't skip it. You're going to most likely need it later. Find bugs. In this case, bugs are your friends, and they live at bugs.swift.org. There's a very neat starter bug label that brings up a lot of the starter bug cases the Swift community have determined that are great for first-time contributors. So going into the first one, later on in this paragraph, it says that we should have benchmarks in the benchmark suite for measuring and detecting any potential regressions for index path. To do that, just open up Apple's developer documentation for the object that you want to benchmark and pick a few methods. In my case, I picked max, min, and the two subscript methods. If you're going to be testing different permutations, make sure you test that in one benchmark. So for example, max, we need to benchmark max at the beginning, middle, and end of an index path. So you want to include that in one benchmark. You're going to need to compile from source, and that takes upwards of 70 gigabytes. On my system, it took about 100 gigabytes, so it depends on what you build for. Set up your environment by first forking the Swift repo, clone the repo, and create your dev branch. Don't postpone that like I did. I postponed it and ended up committing on the main branch. Clone your sources with their update checkout tool that's located in the utils folder of the Swift project. Install and update your dependencies, then build for Xcode or Ninja. Either of these have their pros and cons. I encountered a lot of errors building for Xcode, so I built with Ninja. Ninja allows for faster incremental build times, and if you're worried about having to find your way up and around the call tree, the file structure is pretty well organized, and I didn't really have an issue with that. This is how your build folder will look, your project folder will look like. In your build folder, you have your build artifacts. So for example, in this folder, you have your benchmark drivers that you'll use to run your benchmarks that you build. And you'll be making your changes in this Swift file, in this Swift folder. The fun part is implementing the fix. So we can start doing that. If you're creating a new benchmark, run the create benchmark script and give it a name. Don't name it the object you're testing. So if I'm going to be benchmarking index path, I wouldn't name it index path because the compiler would get confused. At the top of the file, we have our global variables, and we want them to be global so we can offset the benchmark execution time. There are examples in other benchmarks that have fewer global variables than I have, but it was just suggested in the PR that I include these variables as global. We have our tags that basically categorizes the benchmark. So it's a validation, an API benchmark, and an index path benchmark. Below that, we have an array of benchmark infos. So in the name, it just follows a dot notation. The run function is you're just passing in the benchmark function that accepts a parameter of type integer. More on that later. Then you pass in your tags, and then a setup function. Because we're using this variable in this function, we need to pass it into a black hole in this setup function, and that basically helps offset the benchmark time. These functions help us set up those global variables, and that leads me to my next point, that I found out that there are different kinds of functions. So your functions performed in the setup, your helper functions called by the benchmarks themselves, then the benchmark functions. And that's important because you see here we have our inline attributes. Inline always the benchmark helpers, and then inline never the benchmark functions. And that tells the compiler whether or not to include this snippet of code over here, just as if you never called this function. That helps with the benchmark execution time. N is determined by the benchmark driver, and That's basically the number of iterations it takes to run your benchmark in approximately 1 second. This other number here, 10, you notice that it's not there over here. This number, based on my interpretation, I got that number by running the benchmark once and trying to get the execution as close as possible to 1,000 microseconds. There's more detail on that in the Swift guide, but that was just based on my interpretation of it. Another example of passing something into a black hole is when you assign a value, pass it into a black hole to help with the optimizing the benchmark time. Before you can run your benchmark, make sure you build it, then run it with either of these benchmark drivers. The first one optimizes for binary, actually for speed, this one for nothing, and then this one for size. To run it, you can just tell the benchmark driver to give you a list of benchmarks, and then run those specific benchmarks that you want to run. The output is similar to this, where the unit of time is in microseconds. Now you can submit the PR and create the fix. Before you do that, you want to unit test with their lit.py utility, and that's more detail on that in the Swift guide. I'm not going to go through that for the sake of time. You're going to benchmark and compare the new execution time with the past one if you need to. So let's say you're modifying an existing function in the standard library. You want to make sure that your code doesn't slow down everything else. Check your code function. Check your code formatting. Swift format is a great utility. Just make sure you don't format an unrelated part of the file. If you're interested in looking up more on the formatting, you can get examples in other benchmarks. After that, you can commit. So this is an example. This was my PR. If you don't know how to format your PR, you can just pull up similar PRs. In the title, you have in brackets the part of the Swift repo that you're contributing to, in this case, benchmark. Keep the title concise, keep the description concise, and at the end, you put in the case number that it resolves. So in this case, SR 13801. And you see here that we have the 3 different permutations for min and max. I later condensed that into one benchmark, so index path max, index path min, based on some feedback I received in this PR. After submission, a reviewer will pick it up. First-time contributors don't really have the permission to assign reviewers. That's given to people who have commit access, and that's you get that when you have made 5 consecutive perfect PRs to Swift. The reviewers will request changes before asking the Swift CI bot to test and benchmark your code. And if all checks are okay, then they'll merge it. And that's it.